Welcome everybody. This is a really important webinar on regulation. It's certainly something that takes a lot of time in the deployment process. It affects very definitely the quality of what gets deployed, and I think it's one of the ways you can sort of measure the, if you like, the responsibility of an activity is the length of time between when decisions are made and when results may be apparent. And I think a lot of the issues that we're going to be talking about are extremely responsible in that decisions made now by both the project proposers and the regulators will have repercussions for maybe decades to come. So as I say, very important area. We're very fortunate to have three of the organisations very much involved in the permitting activities for all of the CCS deployment in the UK, the Environment Agency, National Resources Wales, and the Health and Safety Executive. Just to repeat, the format is 3 20-minute sessions and then short break, and then we'll have time for discussions and complete questions. If there's any time in the 20 minutes, which I kind of don't expect there will be, we can take a few quick questions for clarification. But if you put questions in the questions area, then we can pick them up later. So without more ado, can I pass on to the team from the Environment Agency? Thank you.
Yeah, thanks, John. Thanks for inviting us along to talk today about our regulation of carbon capture. So just for introductions, I'm John Barraclough. I work in our head office and Environment and Business Directorate, and I'm predominantly working on developing our regulatory approach to carbon capture. So I've been quite closely involved in engagement with industry, with government, and with the development of our carbon capture guidance. Gwenda?
Hi, Gwenda McIntyre. I work in the Environment Agency again, but in the National Permitting Service based in Nottingham. And I work on one of the current applications that we have in process to determine for a post-combustion carbon capture system. I'm also the sector lead for the National Permitting Service for carbon capture and net zero, which is a role I took on quite recently.
Thanks, Gwenda. So what are we going to be covering? So we're doing a double act, so we'll be swapping over as we go through the slides to cover different aspects of the talk. We thought it would be quite useful to just refresh, to recap on our regulatory role in carbon capture. Then also a recap on our regulatory guidance. We do get asked lots of questions about our guidance and about what the status of that guidance is, and whether industry should be following that guidance or not. So I thought it would be useful just to revisit the background and a little bit of detail about that. Obviously, we've been determining a number of applications for carbon capture plants. So we thought it would be really useful to focus on some of the key permitting issues from what we've learned, I suppose, up until now. And then I've got a slide at the end, just one slide on some of the latest developments. I've got a bit of an update on some work we've been doing on developing environmental assessment levels. Okay, so just starting with our regulatory role. So you'll probably be aware that carbon capture for storage is a listed activity under Schedule 1, Part 2 of EPR. It's a 6.10 activity in its own right. So we issue permits for carbon capture for storage using that schedule. Where CO2 is being captured for utilization purposes, there is a slightly different approach, because carbon capture for utilization is not a listed activity at the moment, although we are looking at that with DEFRA. So where applications come forward where they're planning to utilize the CO2, we can permit that as a directly associated activity to that existing installation permit. So for example, I suppose if you had a chemical plant that was looking to capture CO2 and utilize that CO2 in some way, then that plant would likely have an existing installation permit, and we would add on the carbon capture activity as a DAA. Just going on to the background of guidance then. So carbon capture is an emerging technique, so there is no existing BAT reference or BAT conclusions for this activity. Where that is the case for emerging techniques, then regulators have a duty to set permit conditions following Article 14.6 of the Industrial Emissions Directive, and in Annex 3 there are a list of headings that you should cover when carrying out that assessment. So so we followed that process, working closely with UK CCSRC, and back in July of 2021 we issued version 1 of our post-combustion carbon capture best available techniques guidance on gov.uk. Now, I say version 1 because the guidance is constantly evolving. So we will be providing updates, certainly over the next 12 months. There's going to be quite a lot of updates as we gather more evidence. We are just about to finalize some amendments to that guidance to add carbon capture for energy from waste plants, and also to provide some additional clarification around some of the points that have been raised by industry in that guidance. Just to say, the guidance was developed following a review of available evidence that was carried out by UK CCSRC. We were directly helping to facilitate the engagement with industry to help gather that evidence. The UK environmental regulators then looked at that evidence and translated that into guidance, that the guidance that you see on the gov.uk. We regularly get asked about the status of that guidance, particularly by industry, and whether they should be following that guidance. The Environment Agency do expect operators to follow that guidance, but they can propose alternative approaches as long as those approaches lead to the same environmental outcomes. Just a point about the longer term. So the guidance in the longer term will evolve into what's referred to as BAT standards. So the equivalent, I suppose, of a BAT reference and a BAT conclusion. It's unlikely to happen for a few years. In order to set BAT standards, then we need a lot more information about the performance of these carbon capture plants in order to set those standards. Okay, hand over to Gwenda.
Okay, so this slide just illustrates some of the information we expect to see in a permanent application. We've highlighted in bold some of the key issues that we will be discussing in a bit more detail in the rest of the presentation. But just as a sort of in advance of what I'm going to say, is one thing that's very important is when you put when an application comes in, we will expect it to include not just the details about the post-combustion carbon capture or the carbon capture and utilization unit. We also want to see all the other normal documents we would expect to receive in an application, either for a new bespoke permit or for a variation, depending on what the application is. So we would expect, if there was going to be a change in the site boundary, we would expect the site condition report, and other changes to the installation, if there's going to be removal of other emission points or new additional emission points not connected to that, but you want them covered in that variation, then we'd expect that to come in. But key to the carbon capture, we particularly need to see a systematic review of the operating techniques against the post-combustion carbon capture guidance that is available online. And that's the guidance that John's just been talking about, which will be updated as time goes on. And particularly we'll expect to see that lots of things listed in there, but just for example, the energy efficiency, we want to see how you've integrated your post-combustion plant, carbon capture plant into your existing combustion plant in order to maximize the thermal energy efficiency of your plant, your existing plant, and with this in operation with it, and how you're intending to supply the heat and power from the post-combustion unit, post-combustion carbon capture unit, and how that's been integrated in, and you've assessed and designed that to maximize the overall energy efficiency of your process. We'll also need to know your predicted CO2 capture efficiency, which should include the startup and shutdown capture of CO2 during startup and shutdown of your combustion system. We will need to understand the flue gas cooling system. So that's the pre-cooling of the flue gas before it goes into the carbon absorption system, and any flue gas treatment that needs to be performed, which may be in addition to what you may have already been performing if you had an existing plant, and understand how you've come to design that and what key features you're putting in there will help to protect the solvent if you're using a solvent for the capture. In terms of the solvent, we need the details of the solvent. We need to know why you've chosen that solvent as opposed to other types of solvents that may be out there. In that justification, we need to see a comparison of that solvent perhaps with other types of solvents to explain if your justification is based on more energy efficiency, lower water consumption, whatever. We need to see that information. You will need to include your methods that you're going to use to prevent degradation of the solvents, and also the methodology that you're going to apply to remove degradation products with time, whether that's a continuous removal of a bleed or whether you're going to have batch processing of the solvent, whatever. Just that all needs to be part of the application. There's obviously as well the very key to the emissions and control of emissions. You need a full disclosure of your flue gas abatement process, what water washes, what the stages are, whether you've got one or more acid washes for removal of ammonia and other amines if they've used an amine solvent, and very importantly, how you're going to control and prevent aerosol emissions, what your droplet removal is, and how you're going to minimize aerosols emissions, because the aerosols will obviously carry over with them amines and amine degradation products from your capture plant. You'll also need to have plans for what you're going to monitor process-wise, which could be to do with the solvent and the state of the solvent, could be other things, and also what your emissions monitoring plans are. How you're going to deal with unplanned emissions, what those unplanned emissions could be, the known unknowns, I suppose, and very critically, your air emissions risk assessment, which should be to the standards that we have already published for air emissions risk assessment, but taking into account particular needs if you're using amine solvents, that you need to be considering how the discharge behaves and what atmospheric chemistry impacts are on the nature of the degradation products that will reach the receptors. Also, we'll mention a bit more on this later, but we need the CO2 emissions from your process, both routine emissions and also the emergency emissions will need to be assessed, and the modelling data include it with your application. And where you may have emissions to water, not all plant will, but where there is a potential for emissions to water from the post-combustion carbon capture unit, you'll need to include a water quality assessment.
Thanks, Gwenda. You probably noticed we'd highlighted four of those points in particular that we wanted to run through in a little bit more detail. So we want to take the opportunity to reinforce a message about the importance of chemical disclosure. We do understand that some operators or their solvent providers would want to keep their composition of a solvents commercially confidential, and operators can request that as part of the permit application process. However, we do need to know all of the solvent components and concentrations at the top of a stack. our view is that it's reasonable to argue that any of the components that are in the absorber tower are likely to also lead to an emission from a stack. Having said that, it is possible that an operator could attempt to demonstrate that because of abatements or reactions, chemical reactions in the capture plant, the link is broken, then we may be able to withhold the information under commercial confidentiality grounds if it can be proven that that particular component isn't being emitted to the environment. I think, I mean, we've had lots of conversations with industry about this. One of the restrictions we have is under the environmental information regulations. We can't withhold information under commercial confidentiality. So we have to be able to prove that the link wasn't broken. It actually doesn't make it relate to an emission to environment. I think it could be quite difficult for an applicant to demonstrate this. I think in order to demonstrate that, they would have to have a significant number of hours operating a pilot plant using the same design of the plant, the same abatement, in order to and then capture the data from that pilot plant and submit that as part of the permit application. But anyway, we are going through the process of considering applications for commercial confidentiality, and where we can, we will try and work with an operator around those issues. Gwenda, I think you're going to say something about the modelling assessment of emissions to air.
Yeah. So on the in the what John's just been saying there, he's emphasised that we need to know all the solvent components. We need to know the solvent components, but we also need to know the breakdown products within the absorption system. We need to know the concentrations of all the emissions, the amines and the breakdown products at the top of the stack, in order to check the applicant's assessment of the air quality on habitats and the environment. Sorry, the impact on air quality, habitats and the environment. And to do this, we need to know that the nature, the exact nature of what all of these parameters are, in order to be able to check the environmental assessment levels that have been applied are also appropriate. But what's key as well is, because we've got this sort of special circumstance really with the amines that are being released, having the potential for the atmospheric chemistry potential for them to actually convert to, in particular, to nitrosamines in air, we need to know what the substances are being released and how they've been assessed to know that what the changes will be on release to air, and to be able to verify the application emissions assessment. The issue is, in particular, that comes out here, is that in most cases, I think, for many of the amines and certainly for the breakdown products, there are no environmental assessment levels, no EALs in existence for these substances. So what we expect is that the operators will either propose their own, or they will rely on, in the future, for some of the EALs that we are in the process of deriving, which will be published in due course. So that is an alternative. If the applicant is going to propose their own, they need to do that in line with our guidance. They can choose to do that by looking at using a read across method, effectively looking at something that's equivalent or more harmful and using derived EALs for that substance, or they can follow our hierarchy for the derivation of EALs on our website and actually follow through and based on toxicology data and derive their own. In terms of what happens when that is submitted to us, we will review that, and if it's appropriate, we will submit that to our statutory consultee, the UK Health Security Agency, for their assessment and their comment on the appropriateness of those EALs. As I've just noticed, we do have an ongoing project to derive EALs, and John will mention that later in the presentations. In particular, sorry,
carry on, Gwenda.
Just in particular, if you're going to use, if applicants, are going to use solvents other than monoethanolamine, then there is a good possibility that the predicted concentrations of nitrosamines at the receptor will be dominated by the atmospheric chemistry as opposed to the release from the source. So then it just reiterates again, it's very important that we know what the emissions are at the stack so we can check that we agree with how you've assessed that atmospheric chemistry impact on the nature of the chemicals arriving at the receptors. When it comes to the actual air dispersion modelling reports, we also want those modelling reports submitted to us in a format that's in keeping with our guidance. And we need to clearly understand the basis for the scenarios that they've modelled and for the emissions input data that's been used. Thank you.
Thanks, Gwenda. We couldn't do this talk without talking about CO2 capture rates. So our guidance is clear that we expect plants to be designed to capture at least 95% CO2 from the flue gases. Concerns have been raised again about this level of capture, particularly where we've got power plants which are dispatchable and they have to shut down and start up a lot, and we'll likely need to do that more in the future as the proportion of renewables increases. Then these plants are likely not likely to be running as much as they are at the moment. We will accept justification, so an operator can justify in their permit application where there are particularly concerns about periods when they won't be able to capture at 95%, and we will consider that as part of the permit determination process. What we will be looking for, though, is for applicants to demonstrate that they have used our guidance and the evidence review to look at solutions, look at the ways that they can deploy bits of kit to maximize CO2 capture during periods of startup and shutdown. Just to say, there will also be periods when the transport and storage system is likely to be down or not available, and under these circumstances we would expect the CO2 capture plant to be bypassed to allow the power plant to continue to generate power. So obviously during those periods, that wouldn't be part of the averaging of the capture percentage that we expect over an extended period, say 12 months. Okay, that takes us on to CO2 venting scenarios, Gwenda.
Yep, so there will be a need for CO2 venting at some stage for both safety and maintenance purposes from the carbon capture plant and the associated carbon capture and compression plant. It's also possible that the facility may be one which has to provide a safe venting facility for the actual CO2 transport network. And that may be included within the application. It may be necessary to include that within the application. So you'll need to identify the different venting scenarios for both routine, normal operations, where you might routinely be knowing that you're going to have to vent for a particular period while your plant is getting up to normal operating conditions. We'll also have abnormal conditions, which may include emergency venting, in particular emergency venting of large itineraries of large inventories of carbon dioxide. But what's key is that that it's the applicant who needs to identify the worst cases for all of these scenarios. They need to be able to, they need to assess the risks, and they do a full-on risk assessment and detail the risk management techniques to minimize these events happening, and to show what the remaining risk is. Based on that remaining risk, you'll need to submit the emissions assessment for the scenarios, and most likely you will be required to model the emission of the carbon dioxide. Now, this may be that you have, in some circumstances, you'll be able to model using normal air dispersion modeling programs. But where you've got high pressure or very particularly cold emissions, where you've got any situation that risks where the carbon dioxide that is emitted risks behaving as a dense phase gas, you'll need to do specialist modeling using a dense phase gas modeling program. As said, the risk assessment should be for worst case emissions scenarios, so that we can we have an envelope of your worst case impacts for carbon dioxide. If you then, if we decide to issue a permit based on that scenario, and then an operator goes on to design a different or to make changes to their compression system or the venting and operational scenarios, they would be required to, in the permit, to reassess that design, reassess that emission scenario, and if necessary, they'll actually have to apply for a variation to the permit before they can operate the system.
Thanks, Gwenda. Okay, almost say just two more slides. John, I haven't seen you pop up on the screen, so I'm assuming that we're okay at the moment for time. So just to summarize, it's really important that industry engage early with the Environment Agency, and I think because it's an emerging technique, I think really we need to go down the route of operators applying for a formal enhanced pre-application meeting with us, so that we can talk through the specifics of their plant and what the requirements will be in the permit. We're quite happy to have early discussions as we have had with some of the operators, but it is important that they get a formal response, a formal written response to from the Environment Agency through a formal pre-app discussion. We do need to see sufficient detail in the permit applications. We tend to have to send out lots of Schedule 5s for additional information, which causes delays. So just to emphasize that, you know, we do need that level of detail. We can't determine a permit without having sufficient detail. We do know that some of the plants are early stage design, so they're pre-feed. So we don't have all the answers. We do have some flexibility in that we can put pre-operational and improvement conditions in permits, but only to a certain extent. And there will probably circumstances where an operator changes their approach in the future or changes their solvent, for example, they're likely to have to vary that permit. I just wanted to lastly say something about the, it's not on the slide, but if there is some commercial grounds for the application to be prioritized by our permitting teams, and you can request that in writing when you submit the application, and that will be considered. As you can imagine, we get large volumes of permit applications, and we do have a queuing system. But I just wanted to say that there is a way that you can say if there is some commercial grounds there for it to be prioritized. And then the last slide, just very quickly on this, really. So as I don't know whether John was going to say anything about this later, but UK CCSRC and ourselves have been engaging with industry to try and gather some additional evidence for carbon capture where it's used in refineries and cement and lime plants, and also other industrial processes, and that work is ongoing at the moment. Once that evidence has been gathered, then the regulators will look at that evidence and we'll look at amending our guidance as we go forward, perhaps towards the end of this year. And then lastly, just the latest, this is kind of hot off the press, if you like. We did commission Ricardo to do some work to look at developing environmental assessment levels for 15 substances. I don't have a list with me, I'm afraid, but 15 amine substances and their byproducts. They've managed to develop chemical dossiers for 8 of those substances, and there are 7 where there was insufficient toxicological information available to support the derivation of the EAL. So we are looking at how we can address that, potentially looking at read across to other substances. Just finally, next steps on that. You will get the opportunity to see that list and to look at that information. We will be going out to consultation around the end of July or in August for a period of 13 weeks. So everybody will get a chance to comment on those assessments. I think that's back to you, John.
Okay, thanks very much. That's a really comprehensive view, and I think it's hard to underestimate the amount of work that's going on behind this. It'd be very, very interesting to see some of these reports, and I suppose as well as the work that's going on behind it, things like actually getting better data on toxicology.
Okay, so thanks very much. I don't know whether you could hear me, but I was saying that obviously a lot of work represented in the presentation, and indeed a lot of work to come to fill in some of the gaps. And I think UKCCSRC academic members will no doubt get involved with that as well as others. So we're running a bit behind time, so without more ado, please, National Resources Wales. Wales is both hosting capture projects and also CO2 storage off its coast, so very relevant to get some information from them. So, National Resources Wales, over to you, please.
Thank you. Can everybody see the presentation?
Yes.
Yep. Yeah, good. Okay, so I'm Jeremy Walters. I'm the team leader of the newly formed Industrial Decarbonisation Standards Regulatory Approaches team. That's quite a mouthful. I'll hand over to Dave to introduce himself.
Yeah, so I'm David Poole, also in that new team, which I won't repeat trying to say. Prior to that, I come from a permitting background, so a strong sort of synergy with Gwenda there.
Okay, cheers, David. Trying to forward my slides, but for some reason, there we go. So first of all, to say there's a lot of synergies between NRW and the EA. We've got the same primary legislation, so we'll be using the same guidance, for instance, and there'll be a lot of synergies. So today we'll cover what makes NRW different to the other regulators, what our main roles and responsibilities are, and then I'll hand over to Dave to go through some of the challenges and the emerging issues. So our the main reason that we're different is legislation. There's a different legislation framework in Wales, and this is secondary legislation. There's 2 pieces of legislation that affect the way we work. First of those is the Environment Wales Act, and in that, not only does it form NRW, it requires us to work in a certain way, and that way is to use those principles you have on screen there to pursue the sustainable management of natural resources. So we've got to use those principles to deliver our functions. Part of our functions is obviously permitting and regulation. It doesn't give us any more powers, but it does require a different way of working. And those principles you see there boil down to 4 aims, which are the stocks of natural resources are safeguarded and enhanced. We have resilient ecosystems, healthy places for people, and a regenerative economy. So we use those aims and and principles that we covered in this slide to deliver the well-being goals. And the well-being goals are held in another act, which is the Wellbeing of Future Generations Act. And there's requirements in there for, it puts duties on public bodies in Wales, and each body, of which NRW are one, must carry out sustainable development. And we have to publish our wellbeing objectives. So wellbeing objectives are highlighted in our corporate plan that was recently released, and these reflect those SMNR aims and principles. And we've distilled them down to 3, so it's getting less as we go down. And that is nature is recovering, communities are resilient to climate change, and pollution is minimized. So all 3 of those are things that we use to deliver our objectives. And we use those in all our functions. So all those pieces of the jigsaw are applied to our roles and responsibilities, which are numerous, and most of them are on the screen there. So there, for CCS, there are several of those where you will interact with us during the process of getting permission. We are the Nature Conservation Council, so we have a dual function there. We are obviously the regulator. We are also statutory consultee to planning. We also own a lot of land, so 7% of Wales' land area, including the Welsh Government woodland estate, is controlled by NRW, so there may well be wanting to cross that, or some of the infrastructure for CCS may impact on that land, so that is there as well. So those are our main aims and responsibilities, and I will hand over to Dave to cover some of the challenges and some of the more technical aspects.
Thanks, Jeremy. So given that range of responsibilities takes us on to the specifics of the post-combustion carbon capture and storage and the challenges it presents for authorization. I note that in our slides we've used the word authorization, not regulation. I think there's 2 reasons for that. One is it reflects where we're at. We're not there with up and running facilities that we regulate, as we already do for a whole range of industry. But I think implicit in the word as well is the fact that we do recognize they need to be authorized. We've already heard a lot about the challenges, but with our remit, as Jeremy has outlined, we know we've got to find a route through. So it's very, very much on our minds that we need to be finding the solutions to get through the challenges that arise. So in terms of specific challenges we face, I've said dealing with our diverse remit, working out where we interact with the authorization. Specifically, I'm going to pick up on habitats assessment regulations, a bit on the environmental permitting and the information we need, pinch points and gaps. I see the slide went before I finished it, but it doesn't matter. We did collude with John and Gwenda before today, you'll be pleased to hear. Otherwise, the section on environmental permitting could have been an exact repeat of the previous 20 minutes. So we are, again, trying to emphasize any differences as well as the similarities as we're going along. So I think that the first thing to say is the Environment Agency presentation focused, I think, entirely on the EPR permitting of the installation. We do all that, and the EA, in fairness, do other things as well. But I just wanted to say from the start, we're trying to look at this holistically as the decarbonisation industry team. And there are numerous points where you will interact with us through the permissioning of the facility. So for the industrial installation itself, there's EPR as mentioned. You will hear from us again as a statutory consultee to planning. You may need additional consents from us, such as for species licensing. And different parts of NRW act as the statutory nature conservation body. So they will be providing official feedback for any habitats regulations assessments and SSSI consents which are required. So you need to get your head around all of this when working out your permissioning plan, and you will speak to us in different parts of the organization. We're working to try and make sure that is coordinated, but you will hear from us, and we will try to speak with one voice on all of those things. That's the installation itself, the point source. We're also very well aware that the carbon capture has associated infrastructure. I'm going to say pipelines, wider than that, but that's the biggest and most obvious. And we're involved in the consenting of those as well. Once again, whether the statutory the statutory consultee to the planning. NRW is also the statutory nature conservation body for that as well. And once again, you may require additional consent. So I think a web of consenting is the best I can say. And you'll probably find you're talking to us a lot, and to potentially a number of different individuals in the organization. Next one, please, Jeremy. So from there was one specific area I wanted to mention. It's been touched upon in the previous presentation, but I think it's the one where we probably have the biggest issues. I've said it in the second bullet, often the most challenging and potentially slowest part of any authorization. I hope many of you will be familiar with that piece of regulation, but it's the regulation which gives protection to SACs, SPARs, and to Ramsars. I don't intend today to do a full breakdown of what that means and what you're required to do, but the message from us is it's got to be considered early. It is a potential deal breaker to new developments. It's not an add-on. And sometimes in applications we see, unfortunately, it does feel like that. That comment is on all applications, not specifically carbon capture ones. It needs specialist input. It's likely that it will involve ecologists in the application, and the precautionary principle embedded within sets a very high bar. In simple terms, the application has to demonstrate that the protected site will remain protected and won't be harmed. There's no onus the other way around. The onus is all on the application, on the applicant to demonstrate no harm, which is a tough one. So ignore it at your peril, I would say. I think that's enough on that. It's a placeholder. If you want detail, there are other places to go. So that's one element involved in both the planning and the permitting. I thought I'd move now on to the EPR permit application. As we've already alluded to, there's huge synergies between us and the EA here. We collaborate on most of the guidance and standards that we use. So the first point is, expect the technical process of application to be largely like the EA. I don't think there was anything that was said in the previous presentation that I would see any difference between us and them on. So the EA guidance and the guidance on emerging techniques can be used, but simply refer to the web page of NRW for details and application forms, and speak to us about application specific details and pre-app and so on. So that's that. As I said, these slides, they could be a replica of what's already been said. So I've sought to make sure that they're not, and just pull out different facets or say some of the things in different ways. So we've already heard that there's a lot of new technology, novel solvents, concerns about EALs. But one thing I sort of emphasise with both a permitting and an engineering background is whilst some parts of the application are novel, a lot of it isn't as well at the same time. So it's still a form of chemical scrubbing process. It's a form of air abatement. When it gets to the stage of permissioning, it will come with design performance guarantees, specification. There will be evidence from pilot plant and from existing built plant globally. So give us that information. Tell us what we need to know about the process to give us the confidence that it's something that we can authorize and that we can say yes to. And again, our message is, if it's a well-constructed application, we wish to be able to assent to it. We can't do that lightly, but we want to see things get across the bar. We recognize the imperative of getting these plants into operation. So that's that. On to the next slide, please. This list really is it's my version of what's already been said, but it's a plea to help out the people and the individual, the permitting officer, dealing with your application by putting in a coherent application. If I was doing an application, I'd probably sit and use this as a checklist and Gwenda's list as a checklist to make sure you've hit the spots before you start. It probably means involving a consultant who is experienced in detailed permit applications. I would suggest it's not a necessity, but it's likely to help. So in terms of my list of asks, I've said resolve your questions before you put in the application. Do the pre-app advice. We can have discussions, but that's pre-app. Once the application is in, we don't like people changing things or saying we could do this or this. It needs to be a definite application that we can assess. It needs to meet all the requirements of a standard permit application for any installation, as Gwenda has said, in that it needs a clear non-technical summary. It needs to explain what is going on. That's likely to include process flow diagrams and written description. The key decisions need to be explained and referenced to BAT and the guidance on emerging technology. I think, again, something that we frequently see is we're presented with your decision, but not your decision-making process. And that makes it more difficult for us. If we can see where your constraints are and why you came up with your proposed design, it makes it easier to agree that that is BAT overall. Comprehensive environmental risk assessment is what I've said, and then detailed assessments to support the overall risk assessment. So earlier we heard about CO2 venting. I would say that is one type of specific assessment under the overall environmental risk assessment. So it's different ways of saying the same thing. Either way, we agree that it's a necessary component. We are expecting to see associated plant changes alongside the carbon capture variation. So most likely additional gas cleanup, that needs to be included, described and documented in the standard way and assessed for its environmental impact. And then getting close to the end of the list now, but I thought it was worth emphasizing potentially for this audience, the permitting is a legal and, dare I say it, bureaucratic process. You have to hit all the bars as you go along. And one of those are specific legal requirements. I think people are familiar with the guidance on emerging technologies, BAT, where it exists for the process. But there are also the requirements of IED and the specific chapters for combustion and for incineration. And if there's anything that's being changed by the carbon capture, we need to see how that is going to be attained. One of the obvious things which has arisen is, how do you demonstrate that you're still meeting the IED chapter emission limits with the monitoring that you will undertake post carbon capture or pre-carbon capture, depending on your proposed approach. One last plea towards the end is please keep the documentation relevant. As you can see, it's a very busy slide. I apologize for that. There's a lot necessary to the application, but we do still see a lot of stuff which is superfluous. I've seen entire planning applications just replicated into the EPR permit. If it's going to take us 2 days to wade through, that's 2 more days on the determination time. So try and make it as easy for us and as navigable as possible. And bearing in mind that, with notwithstanding any confidentiality claims, these documents will be put on the public register. It should be accessible to members of the public as well to understand the content as far as that's possible. And then again, John has referred to Schedule 5s and questions during determination. Seek to head as many of those off as possible before you put the application in, but do expect them as well. And if we do send a Schedule 5 asking for information, make sure that you're happy with what we're asking, why we're asking it, and make sure that your response hits our needs and expectations. I think sometimes there's a sort of issue of we send a letter, maybe have a meeting, and then get a response back which doesn't answer all our questions. So make sure you understand the ask. And within that, I think it's not here in the words, but don't try and hide anything which is a difficulty for you. If there is something where you simply don't know yet, or you know there is competition between 2 competing factors, discuss it with us, discuss it as necessary in the application, because if there's just a bit missing, we'll keep digging. If you explain what the constraints are, we've got something we can work with and come to a solution. So that's that. Next slide, please. And I think this is the penultimate one. This is really a list of the pinch point issues. Again, complements what we've seen before. We're aware of the design envelope and uncertainty when applications come in. It's the nature of it. Again, that isn't totally novel to us. We're used to some uncertainty in the design envelope. We will try and work with that. If you can specify your application to be flexible to the uncertainty in the design at the time it's that the application goes in. That said, no permitting is a static system. Assuming you get the variation or the new permit you need, expect things to be changing over time. BAT will develop, as John has already said, so the permit will change. So you be ready for that. Don't let that come as a surprise, and that will be informed by the operational data that's generated as plants come online. We've already talked in previous presentation about the equipment selection and the solvent selection and the commercial sensitivity. I've nothing now to add to that. In the same way, there is the whole issue as to what is BAT, or guidance on emerging technology. Again, we're in the same place. We use the same guidance. We expect you to look at that, refer to it, explain any deviations, but we are open to a justified explanation of a deviation from that anticipated standard. The air emissions risk assessments are once again the same issues, and the EALs, that's been well described already. I think the only thing I would add to that is from a personal perspective, I hope that settles down in future years. It's quite difficult at the moment. I think that will get easier as this becomes more mature. That's my hope, at least. The habitats impact I've already covered, but I think it's worth saying the key headline to me here is ammonia, and as well as any substance specific EALs for the amines and breakdown products, it's the total N loading on already overloaded habitats. So that's where our interest lies. And then seemingly relatively trivial things, but those questions which are key to permitting of how and where are emissions going to be monitored? How do we make sure they meet the IED requirements of the underlying processes I've touched upon? They are quite difficult questions. There is work by the CCSA, etc., trying to develop standards. But again, at the moment, it's a question of make your proposals, be prepared to be flexible if we don't accept the way you've proposed it, but justify it, explain what is best for your process. And then, as has already been talked about, the pinch point about the capture efficiency, and that brings in plant availability and other than normal operating conditions as well. I think they go very much as a package, and depending on the industry to which you're looking to fit carbon capture, all of those three parts are very much interlinked. The capture efficiency, as John spoke about, I think he probably had power plant in mind. I think the one we're expecting first is cement. And it's the same question, but again with slightly different facets. But the message is explain your constraints, explain what you can achieve when the equipment first gets in, I would say, but also what your aspiration is in terms of capture efficiency down the line. We recognise there's going to be extended commissioning on these. It's not going to be perfect straight in. So again, use the application to set the bounds of what you think can be achieved and what you will then be tied to by the permit. I think that's nearly, sorry, I thought that was it. One more. So again, the future research need, the gaps at the moment, I don't think there's a lot new here. So the impact and toxicity data we've talked about. We haven't already mentioned, but there is a gap in terms of fit for purpose and standardized emissions monitoring for those same substances. That's self-explanatory, I hope, but it's an urgent need, I would say, as soon as these plants come online, to have methods with which we have confidence and which are both fit for purpose and simple enough to deploy through the MCERTS route. Data to inform future applications and what is back. It is all new. The more data we have, the more we can home in on what is reasonable, who are the outliers, and look at post implementation process optimization, which it's a scary area to be in, but that's where we're at. I've then said my focus now, I used to be a researcher, but my focus now is on permitting and what's going on now. What does the future look like? Are we going to be talking amines forever, or is there a second generation? And any information coming forward will be of great interest, and what benefits that gives and what new challenges that throws up. And alongside all the carbon capture side and CO2 capture, the team is looking with one eye in each direction. There's all the carbon capture, but there's also the hydrogen generation and combustion, and the regulation and engineering needed around that. So it's like we've got to look at this holistically. So again, obvious issues like NOx from hydrogen generation, if it's going to be blue hydrogen, carbon capture associated with that, and so on. So keep an eye on the bigger picture. And I think that's all I was going to say at this stage.
Hey, thanks very much. I mean, we are running a little bit late. I make the real apologies for that, because it's all very interesting stuff. I think we'll go straight into the next talk, though, from the HSE, and then we'll take a short break after that, and then go into questions. And we'll have a hard stop at 3 o'clock. Okay, HSE, please.
So yeah, this is going to be another double act presentation with myself and Martin Wayland here. So I'm going to start with some introductory stuff and talk about science knowledge gaps, and then hand over to Martin to talk about regulation and the concluding parts. Quickly then, HSE is the UK regulator for workplace health and safety, and that includes all onshore and offshore pipelines, other chemical, oil and gas infrastructure, and so on. And we cover a range of activities from evidence gathering all the way through to enforcement. We're keen to act as an enabling regulator, for new technologies like carbon capture and storage. So I work within the Science and Research Centre part of HSE that's based in Buxton, where we've got laboratory facilities and a test site. I thought it would be useful to take a step back. So thinking historically back to 2007, some colleagues published this paper on knowledge gaps on CCS. And at the time, they raised a number of issues to do with the unusual behavior of carbon dioxide, the way it can form solids, Joule-Thomson effects, some other issues to do with running ductile crack propagation in pipelines. So over the years since 2007, there's been quite a number of projects that have addressed these issues, but there are some knowledge gaps that still remain to be addressed. So the next couple of slides have come from an engineering materials lead here at HSE, Adam Bannister. I wasn't going to go through these in a huge amount of details because it's really his area rather than mine, but there's still some uncertainties to do with corrosion rates. And although, I mean, the principle is to dry CO2 streams before you put them into pipelines, there may be issues with process upsets. So understanding corrosion rates, how you inspect and maintain pipelines is going to be important. There's issues around fracture propagation, brittle and long-running ductile fractures. I know there's been a lot of work on that recently, and I'll come back to that in the next couple of slides. Yeah, so there's a lot of interest around effective impurities, and I think it's well known now that the Battelle two-curve method isn't it's not conservative, and there's a lot of work to adjust or come up with a revised method for that. And Adam's also talked here about test methods and uncertainty in using them. So that recent work on ductile fractures, so there's a couple of papers here that have been published. I think there's work ongoing to include the findings from those into the DNV recommended practice F104 and this ISO standard as well. And from what I understand, some operators are also considering further CO2 pipeline rupture experiments that may feed into this guidance and those standards as well in the future. So we'll be keeping an eye on progress in that area. Some other issues that have come up around dry ice formation with CO2 and the sort of safety issues. So in the reports on that Satasha pipeline incident in the States, they talked about how in the past some of the valves have been blocked in the open position due to dry ice formation. So I've not really seen any work in the literature that's reviewed operational practice, incidents like that, what the design of the valves were in that case, or operating procedures, and how that sort of incident can be avoided in the future. So there's some gaps around issues like that. And the other issues around, particularly with pipelines, I guess, is around the dispersion of CO2 if you do have a release. Thinking of that Satasha incident, where it was demonstrated that the toxic cloud could go quite a long way because of the fact that it was denser than air and it could travel down slope. And the main sort of knowledge gap that we've got there is the dispersion models that typically get used for risk assessment. So models like DNV FAST or TNO-FX, and models that we use internally in HSE as well, don't account for terrain. We do have some models that can account for terrain in principle, like CFD, but they're not really able to run fast enough to use them along the full length of pipelines. And moreover, there's a lack of data to validate any of those modeling approaches. So we have, over the last few months, been talking to a number of groups about addressing that knowledge gap. And we're trying to pull together at the moment a joint industry project to address that issue, which would involve undertaking field scale experiments on dispersion of CO2 from pipeline releases in complex terrain. And in parallel, bringing together a sort of collaborative group to develop and validate fast running dispersion models that could be used for pipeline risk assessment and emergency planning and response. So as it stands at the moment, that proposal consists of 4 work packages that are listed there. So some work on pipeline craters and source terms, some simple terrain experiments, so uniform terrain without changes in surface roughness, some more complex terrain experiments, and then a work package on model development and validation. And the two test sites that we've been talking to that would be involved in this proposed project, DNV Spade Adam, who've got a lot of experience in running CO2 pipeline rupture and puncture tests. They've got quite a remote location and complex terrain there. And the other test site is DSTL's Portendown test site. So they're well known for doing atmospheric dispersion tests. HSE has used them a few decades ago now, which are the picnic trials. And they've got, unlike Spade Adam, they've got some nice areas with fairly uniform slopes that could be useful for these dispersion tests. So the aim is to leverage the benefits of those two test sites and to have an open model development exercise similar to, there's a US-led project called Jackrabbit that's taken that approach in the last few years. Another thing, or a few other things I wanted to touch on briefly. So there's some key standards and recommended practice that HSE engages with and looks to for good practice guidance. So there's some good work from the ISO TC265 committee in producing these ISO standards. We're aware that there are these two useful documents produced by the Energy Institute on hazard analysis and good plant design and operation. Those are undergoing revision at the moment. In fact, it's on my list of things to do to review them, the recent updates. There's like I mentioned before, this recommended practice from DNV. I understand that there's a joint industry project called CO2 Safe Pipe to update this guidance that I think is going on at the moment. I've tried to find more information about that and have contacted DNV but not had any response. So if anyone from DNV is on the line, then please get in touch if we could have more access to that. Other key standards is obviously PD8010 for pipeline systems. And I was in the US a few weeks ago and heard about some work by the Pipeline Research Council International, PRCI, that are undergoing or have commissioned a review of CO2 pipeline operational practice. It's some work contracted out to the Italian organization RENA. I've seen sort of an outline scope and that looks quite promising. So I'm looking forward to reviewing that in more detail. So yeah, in terms of concluding this sort of first section on knowledge gaps, I think there's the knowledge gaps that I've identified just then it's not super comprehensive. I mean, we've got other issues that we're aware about. They've focused on CO2 pipelines because that's been a lot of our interest in recent years. There's other gaps like the fact that various projects are transporting CO2 by ship in a refrigerated state. As far as I'm aware, there's never been any release experiments to understand how CO2 would behave from that refrigerated state, which is important for ship transport and thinking about northern lights. And, you know, if the CO2 is released onto water from a ship, would it produce rapid phase transitions? I think there's some important gaps there. These issues are international, so I think it's really good to work collaboratively. I know that there's some work underway to address the gaps, and it'd be really interesting to hear about any other work that's ongoing that we're not aware of. So, I mean, these gaps, I've mentioned them at other UK CCSRC meetings, and I mean, in the last 5 years, we've had practically no engagement with the academic community on safety issues with CCS. We've not been invited to be involved in any projects or anything like that. There's only one that's come in the last few months. So yeah, it'd be great to have more engagement on that front. And yeah, if you're interested in hearing more about this proposed dispersion project, then please get in touch. And without ado, I'll hand over to Martin for the next few slides.
Yes, thanks, Simon, and thanks, John, for giving us the opportunity to speak to you all today. So I'm Martin Wayland. I'm a Principal Specialist Inspector with HSE's Energy Division, and I'm also the division's lead for Net Zero Transition. So Simon's covered the scientific aspects relating to CCS, and I'd like to take you through the health and safety regulatory aspects of CCS from a policy and operational standpoint. I sit more on the operational side of the fence, so that's my sort of field mainly. So HSE is actively engaging with Great Britain CCS projects such as HyNet and the East Coast Cluster, which are the links are both displayed there, and both through industry and government working groups, including the Carbon Capture Storage Association's Health and Safety Working Group, to gain further understanding and greater understanding of the health and safety risks associated with CCS operations. Next slide, please, Simon. As with other work activities conducted in Great Britain, CCS projects from design to redundancy attract duties under the Health and Safety at Work Act, and all CCS operators have duties under the Act to reduce risk to both their employees and the wider public, and to ensure that hazards are identified and that risks are properly managed. The Act provides an umbrella under which a number of more specific regulations relating to different activities set, and there's quite a number of those. Next slide, please, Simon. So health and safety regulations are to a large degree differentiated for on and offshore activity. For example, regulations such as COMA is predominantly, well, is onshore specific. COMA is based on the United Nations globally harmonized system for classification of chemicals, but CO2 doesn't have toxic properties within the limits of the classification as acute toxic. HSE is working to obtain further evidence on the major hazard risks associated with large-scale onshore storage and processing of CO2 to inform HSE's regulatory position. HSE is also working with environmental regulators as part of the COMA competent authority to ensure that environmental risks associated with CO2 are also considered, and you've heard from our colleagues from the environmental side of the fence. PSR covers both on and offshore activity. It's one of those unusual ones, essentially. And regulates pipelines from essentially the cradle to the grave, from design to decommissioning, and transporting a wide range of materials. And additional duties within the regulations are placed upon those operating pipelines transporting material with the potential to cause major accidents. HSE recognises that the different phases of CO2 may have different health and safety impacts, and is working with stakeholders, and that's both the industry, the scientific community, standards bodies and co-regulators, to obtain further evidence to inform any regulatory change that might be required in the future. HSE has initiated a 4-year programme of work to develop modelling capability for CO2 pipelines to support HSE's role as a statutory consultee to the planning system. So that's NSIP and local authority planning applications. Early engagement with duty holders who are planning to construct or operate CO2 pipelines has indicated that they intend to operate in line with PSR and are treating CO2 as a dangerous fluid. Okay, next slide, please, Simon. This is aimed at the offshore side of the discussion. So offshore, HSE's regulatory assessment indicates that existing offshore legislation may apply to the transport and storage of CO2. However, the exact arrangements of the operation may impact on how the regulations apply more widely. HSE is now considering potential regulatory amendments to clarify the application to CO2 operations offshore. As with any onshore engagement, engagement with offshore operators who are currently developing CO2 projects has indicated that they intend to voluntarily follow the requirements of the existing permissioning regimes. Next slide, please, Simon. So as you can see, I think across the board here, both from a health and safety and an environmental perspective, CCS presents a number of health and safety regulatory challenges. The HSE is working to understand the associated health and safety risks as more evidence comes to light. A proportionate and credible health and safety regulatory framework is vital to ensure effective regulation. This framework must be informed by evidence. And more pertinently for today, it's a day when many of us within HSE and the wider offshore community reflect upon the loss of life associated with the Piper Alpha disaster, which was 35 years ago today. It serves as a timely reminder of the importance of a robust health and safety regulatory framework to meet the challenges that will be posed in the future by CCS. Thank you.